Next up, we have Dasomie, who has biochemistry / molecular biology thesis, and right after we've got Jonathan, and we're going to wrap it up with Jamie. Okay, almost at the end. All the best.
So diabetes is a prevalent disease in the world today, affecting nearly 40 million Americans in the US alone. Thankfully, we have drugs like insulin that help diseases like diabetes. Many of you have heard of what insulin is. Some of you may even know friends or family who need to take insulin to control their diabetes. However, most people don't really think about the structure or the mechanisms that pharmaceutical industries use to produce these life-saving drugs. So on the top left corner over there is an oversimplified version of the structure of insulin. It is a cyclic peptide that has a special characteristic called a disulfide bond, which essentially is two sulfurs denoted S on the figure that are joined or linked together. So the goal of my senior project is to create a new method for forming these disulfide bonds. My reaction scheme is on the bottom left corner over here. So we start with a peptide that is in its original state, which has a sulfur with a hydrogen still attached onto it, denoted H on the figure. Then we first put this peptide into a basic or alkaline environment, which basically will tug the hydrogen away from the sulfur, leaving the sulfur with a negative charge. Then this next step is the most unique or most important step in my scheme because it's unique to all the different methods that we currently have. And this is, we use something called ultrasound-Assisted, which is on the top right corner. And essentially what this is it's a water bath, and we put our peptide into this water bath, and we add mechanical waves into the water, and this will help facilitate the reaction by adding a radical onto the sulfur. And the radical on my figure is denoted as a dot, and that's also what is standard for the chemistry world. And this radical is highly unstable, and that is why it wants to form a bond with each other. And I confirm that after this reaction scheme that I have made the disulfide bond formation by testing its mass. And as for my results, I was able to successfully test this method on 6 different peptides. And so why is this important? It's important because this simple reaction scheme actually has a really high yield. We have a 95% plus conversion rate with minimal impurities. Secondly, it has great applications in pharmaceutical industries and drugs like insulin. And lastly, ultrasound sonication is actually very environmentally friendly because the only thing you need is water compared to the other methods that require toxic chemicals. And so in this era of climate change, it is very important to have this method that minimizes toxic waste while still being able to produce life-saving treatments. Thank you.